Need extra money for college? ISL Education Lending Scholarship Program provides $1,000 for college expenses. Registration is easy and no essay is required. Visit www.iowastudentloan.org/register to learn more. The scholarship is open to Iowa residents who are in high school and college students, as well as parents of those students. Register by November 30th for your chance at one of the 45 awards at www.iowastudentloan.org/register.
Come unwrap some holiday magic this season in Denver, where the lights are brighter and the shopping is grander, where the season feels a whole lot more wonderful. Discover great hotels and more things to do at milehighholidays.com.
This is SpaceTime, Series 23, Episode 139, for broadcast on the 25th of December, 2020. Coming up on SpaceTime, a new study warns that the new solar cycle could be one of the strongest on record. A solar eclipse plunges southern Chile and Argentina into darkness, and your guide to buying a telescope. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
In direct contradiction to the official forecast, a team of scientists led by the National Centre for Atmospheric Research are predicting that the new solar cycle 25 could be one of the strongest since record-keeping began. A report in the journal Solar Physics predicts that the new solar cycle, which the Sun is now easing into following a deep solar minimum, will peak with a maximum sunspot number somewhere between 210 and 260, and that would make it one of the most active ever observed. The solar cycle, which just ended, peaked with a sunspot number of 116, and the consensus forecast from a panel of experts convened by NASA and the National Oceanographic and Atmospheric Administration, NOAA, is predicting that sunspot cycle 25 will be just as weak, with a peak sunspot activity number of around 115. Now, if the new higher forecast proves to be right, that would support the author's hypothesis, detailed in a series of papers published over the last decade, that the Sun has overlapping 22-year magnetic cycles that interact to produce the well-known 11-year solar cycle as a byproduct. The 22-year cycles repeat like clockwork, and they could be key to finally making accurate predictions of the timing and nature of the 11-year solar cycle, as well as many of the effects they produce. Roughly every 11 years or so, the Sun's magnetic field completely reverses polarity. Its magnetic north and south poles switch places. It then takes another 11 years for the Sun's north and south poles to flip back again. This solar cycle affects activity on the surface of the Sun, such as sunspots, which are caused by the Sun's magnetic fields. And as the magnetic fields change, so does the amount of activity on the Sun's surface. One way to track the solar cycle is by counting the number of sunspots. The beginning of the solar cycle, solar minimum, happens when the Sun has few, if any, sunspots. It's where we've just been over the last few months. But over the next 5 or 6 Earth years, the number of sunspots gradually increases, eventually reaching peak activity, known as solar maximum or solar max, before steadily decreasing again to a new solar minimum. Giant eruptions on the Sun, such as solar flares and coronal mass ejections, also increase during the solar cycle. And these eruptions are important because they send powerful blasts of energy and ionized material into space in the form of geomagnetic storms, sometimes called solar storms or space weather events. The ionized material includes protons, electrons, and alpha particles or helium nuclei. And if these events hit the Earth, they can overwhelm the planet's magnetosphere, which shields the Earth from the constant stream of charged particles flowing from the Sun and the solar wind, and from deep space in the form of cosmic rays. As powerful solar flares and coronal mass ejections crash into the magnetosphere, they travel along the magnetic field lines towards the north and south magnetic poles, triggering the spectacular northern and southern lights, the aurora borealis and aurora australis, as they interact with atoms and molecules in the atmosphere. But these charged particles are also dangerous. They dramatically increase radiation levels for astronauts and even people in high-flying aircraft. And they can also damage or destroy spacecraft by affecting their delicate electronics. And they can shorten the spacecraft's life because they cause the atmosphere to swell, increasing atmospheric drag, resulting in orbital decay on a spacecraft. And these geomagnetic storms also interfere with navigation and radio communication systems, both in space and on Earth. And they overload terrestrial power grids, blowing transformers and causing widespread blackouts. So, space weather is something we want to keep an eye on, no pun intended. The study's lead author, Scott McIntosh from the National Center for Atmospheric Research, says scientists have struggled to predict both the length and strength of solar cycles because they lack a fundamental understanding of the very mechanism driving the cycle. Now, if this new hypothesis proves correct, it'll provide evidence that the author's framework for understanding the Sun's internal magnetic machine is on the right path. Previously, McIntosh and colleagues outlined a 22-year extended solar cycle using observations of coronal bright spots, ephemeral flickers of extreme ultraviolet light in the solar atmosphere. These bright points can be seen marching from the Sun's higher latitudes to the equator over a 20-year cycle. And as they cross the mid-latitudes, the bright points coincide with the emergence of sunspot activity. McIntosh believes the bright points mark the travel of magnetic field bands which wrap around the Sun. When the bands from the northern and southern hemispheres, which have oppositely charged magnetic fields, meet at the equator, they mutually annihilate one another, leading to what's called a terminator event. McIntosh says these terminators are crucial markers on the Sun's 22-year clock. That's because they flag the end of one magnetic cycle, along with its corresponding solar cycle, and then act as a trigger for the following magnetic cycle to begin. While one set of oppositely charged bands is about halfway through its migration towards the equatorial meetup, a second set appears at high latitudes and begins its own migration. While these bands appear at high latitudes at a relatively constant rate, every 11 years they sometimes slow as they cross the mid-latitudes, which appears to weaken the strength of the upcoming solar cycle. This happens because the slowdown acts to increase the amount of time that the oppositely charged sets of bands overlap and interfere with one another inside the Sun. The slowdown extends the current solar cycle by pushing the terminator event out in time. And shifting the terminator out in time has the effect of eating away at the sunspot productivity of the next cycle. When the authors looked back at over 270 years of observational records of terminator events, they found that the longer the time between terminators, the weaker the next solar cycle was. And conversely, the shorter the time between terminators, the stronger the next solar cycle is. This correlation has been difficult for scientists to see in the past because they've traditionally measured the length of a solar cycle from solar minimum to solar minimum, which is defined using an average rather than a precise event. In the new study, McIntosh and colleagues measured instead from terminator to terminator, allowing much greater precision. While terminator events occur roughly every 11 years, marking the beginning and end of a solar cycle, the time between terminators can vary by years. For example, Sunspot Cycle 4 began with a terminator in 1786 and ended with a terminator in 1801. Now that's an unprecedented 15 years later. And the following Cycle 5 was incredibly weak, with a peak amplitude of just 82 sunspots. In fact, that cycle became known as the beginning of the Dalton Grand Minimum. Meanwhile, Solar Cycle 23 began in 1998 and didn't end until 2011, 13 years later. While Solar Cycle 24, which just ended, was quite weak as well. But it was also quite short, just shy of 10 years long. And that's the basis for the new study's bullish prediction that Solar Cycle 25 will be strong. McIntosh says once you identify the terminators in the historic records, the pattern becomes clear. A weak Solar Cycle 25, as the community is predicting, would be a complete departure from everything that the data's shown up to this point. Needless to say, we'll keep you informed. This is SpaceTime. Still to come. Thousands watch as a solar eclipse plunges Chile and Argentina into darkness, and SpaceX launches the same Falcon 9 booster for the 7th time. All that and more coming up on SpaceTime.
We can stop HIV, Iowa.
A person living with and being treated for HIV can take one pill a day to protect their own health and prevent HIV from passing to sexual partners.
We call it U equals U. Undetectable equals untransmittable.
Visit StopHIVIowa.org.
Thousands of people across Chile and Argentina have turned their eyes to the skies to witness one of the great wonders of the cosmos, a total solar eclipse, which plunged the land into darkness for around 2 minutes last week. Heavy rain had threatened the spectacle, but the clouds parted just enough for the phenomenon to be partially visible across southern Chile. The event was the second solar eclipse in Chile in 18 months. Meanwhile, across the border in Argentine Patagonia, there was no rain, but there were strong winds which kicked up lots of dust, also threatening visibility. Despite COVID-19 restrictions, hundreds of thousands of tourists had travelled to towns near the line of totality to witness the event as it unfolded. Local tradition claims a solar eclipse signifies the temporary death of the sun during a battle between the sun and an evil force known as Wikufu. Indigenous people would light bonfires and throw stones and arrows into the air in order to help the sun win the battle and defeat Wikufu. This is SpaceTime. Still to come, SpaceX launches the same Falcon 9 booster for the 7th time, and your guide to buying a telescope. All that and more coming up on SpaceTime. SpaceX has successfully launched a new Sirius XM telecommunications satellite into orbit. The mission from Space Launch Complex 40 at the Cape Canaveral Space Force Base in Florida was even more remarkable, as it was the 7th flight for the same Falcon 9 core stage, which then returned to the surface, landing on the drone ship Just Read the Instructions, which had been pre-positioned downrange in the North Atlantic Ocean.
F9's in startup.
Meaning that the flight computers have taken control of the launch countdown for Falcon 9. First and second stages are beginning to pressurize for launch.
LD is go for launch.
There we heard the final call. LD is go for launch. Everything looking good for an on-time liftoff today.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. And we have liftoff.
Stage 1 propulsion nominal.
Vehicle's pitching downrange.
Falcon 9 is preparing to pass through max Q, which will happen at T plus 1 minute and 12 seconds. For those of you that might be unfamiliar with this term, max Q is when the vehicle will experience the greatest amount of dynamic pressure. Call out there that everything is looking nominal for first stage. To prepare for max Q, we throttle the engines down and then back up about 20 seconds later. And this helps ensure that we keep those dynamic pressures below a certain level.
Falcon 9 is supersonic.
So there we heard the call out that the vehicle is now going faster than the speed of sound.
Vehicle is experiencing maximum dynamic pressure.
So there we heard the call out that the vehicle is passing through max Q. MVAC chill has begun, so that super chilled liquid oxygen is flowing through the turbo pumps, allowing them to cool off prior to full flow of propellant. Everything is looking good with stage 1 trajectory. Coming up, we're going to have 3 events happening in quick succession. We're going to have main engine cutoff, followed by stage separation and SES1, or second engine start 1.
And MECO.
Stage separation confirmed.
We have confirmation of stage separation, as well as MVAC ignition.
Good MVAC ignition.
The mission carried the 7,000-kilogram SXM-7 next-generation radio satellite into orbit. The SXM-7 is based on Maxar Technologies' SSL-1300 satellite bus equipped with S-band transponders and enough fuel for a 15-year lifespan. This is SpaceTime. Still to come, our guide to buying your first telescope. And later in the science report, how well do dogs really understand what you tell them? All that and more still to come on SpaceTime. If you're looking for a present that can be educational, thoughtful, even life-changing, and you're listening to this show, you've probably already thought about a telescope, but dismissed it because top-of-the-line telescopes can be really expensive. But as Jonathan Nally, the editor of Australian Sky and Telescope magazine, explains, affordable, decent telescopes are around, and there are lots to choose from.
We've got a full guide in the January issue of Australian Sky and Telescope on how to choose your first telescope, all the different kinds and the different things you've got to take into account. And look, it's actually not hard. It can seem very confusing and bamboozling because, you see you go into a store and you see the telescopes and they've got all sorts of facts and figures quoted and magnifications and things and apertures and all sorts of of stuff on the sides of boxes, and it all makes no sense because you're not into astronomy yet. You don't know what it all means. But really, it is fairly simple if you just stick to the basics. And the interesting thing is that I've been giving people advice for probably more than 30 years on how to buy their first telescope. And despite changes in technology, that advice has barely changed. It's pretty much all the same. So the first thing you start off with is there are basically three kinds of telescopes. You've got reflectors, refractors, and compound telescopes. The middle one, refractor, is the one that people would picture in their mind as being a telescope, a long, thin, white tube, and you look through one end at the light coming in the other end. That's what a refractor is.
This is what a pirate would use.
What a pirate would use, yeah. And the typical sort of one that you just picture, just a long white tube on a tripod. So you look through one end, that's a refractor. Now that uses lenses. It's got lenses up the front and it's got lenses down the back. And there's nothing in the way inside the tube to block the light going through. It's just an empty tube, so the light comes in the front, comes out the back. That's where you look, and that's where you do your magnification. Really easy. The other kind is called a reflector, where again you've got a tube, usually a wider tube, and what happens there is down the bottom end of the tube is a curved mirror. It's a round mirror, but it's also got a curve on its surface, a very, very slight curve. So when the light that comes in the front of the tube bounces off that curved mirror, it goes back the other way again, and then comes to a focus, and you look through usually up the top front end of the telescope. That's called a reflector. And a compound telescope is where they put the two sort of things together. You have lenses and mirrors. And typically what that enables you to do is get a fairly large telescope with a short tube, because refractors, the typical one you'd picture, the one I was discussing first, as you get bigger and bigger in these refractors, get bigger and bigger ones, the tube becomes longer and longer and longer and longer, and they become quite big. And they're expensive when they get big, refractors, because the lenses are high precision optics, and the tube just gets big, and you need a big mount to put it on, nice heavy mount, so they tend to be fairly expensive. Reflectors, on the other hand, where you've got a tube with a mirror down the bottom, they can be really cheap because they're pretty simple, pretty basic. The mirror is just a piece of glass with some silvering on it, very high-tech made. They're very good, but much, much cheaper to make. So you can get bigger bang for your buck out of a reflector than you can from a refractor. And the compound one, as I said, sort of makes the best of both of those two designs, puts them into one, and then you can get, say, a really portable telescope that has a fairly large size.
And there's a lot of maintenance involved with the different types too, isn't there? Not so much with the refractors, because they're pretty well sealed, but with reflectors and compounds, you've got to keep them clean and dust-free.
Well, yeah, I wouldn't say there's a lot of maintenance involved. You're quite right with the refractor that because the tube is sealed, you've got lenses up the front, completely seal the front of the tube, and you've got lenses and things down the back that completely seal the back of the tube, so no dust can get inside the tube. You keep your lens caps on. You put a lens cap over the front of the tube, and you keep your lens cap on the back of the tube. Just keep it clean. Everything, you won't have any dramas there. With reflectors, because the tube for the reflecting telescope is generally open, and in fact sometimes they don't even have a tube. They just use what's called a truss design, which is like girders. So it just like 4 bits of wood or metal, completely open, space in between. That's actually quite good, because it enables the air to sort of flow through and not have any sort of thermal currents build up inside, which is what you get with a tube sometimes, particularly one that's made of metal. With those ones, yeah, from time to time, you've just got to do some little adjustments to keep all the optics aligned, but that's not really hard these days. You can get 50 little devices you can put in that help you align them. They're quite easy. Compound telescopes, again, from time to time, and I'm talking maybe a handful of times per year, if that, you might want to give them a little adjustment, but if you look after them, you don't throw them around, they're going to be absolutely fine, because they're very well made these days. So that's the types of telescopes you can get. Perhaps one of the most important thing is getting a good, solid, heavy-duty mount, because honestly, there's I was going to say nothing worse. There are plenty of things worse, but in terms of astronomy and stargazing, there is nothing worse than you're looking through a telescope and you bump it, and because the tripod is not strong and sturdy and stable, the telescope then shakes on its tripod, and you're looking through the eyepiece and everything's just wobbling, and it takes 30 seconds to settle down, and it's just dreadful. And every time you get to the slightest little bump, it wobbles again, and you've got to wait for it to settle down. So you really want to get a good, steady tripod done. There's no point getting a expensive telescope tube and putting it on a rubbish tripod. It's like having good tyres on your car. You've got to have a good tripod. There are other kinds of mounts. There's a thing called a Dobsonian mount, which is a tilt and swivel type mount. They're very good and they're very cost effective, and lots of telescopes come with those these days. So basically, whatever kind of mount you're going to go for, just see if you can try one out in the store beforehand. Make sure it's nice and steady. Okay, because that is the main thing.
Equatorial mounts and things like that, exactly how you have your telescope positioned on your tripod?
Yeah, look, equatorial mounts, that's where you can set the telescope up so it's angled at a certain angle up to the sky, and that way you can then make the telescope track or move with rotation of the Earth. If I was a beginner, I wouldn't get into equatorial mounts. I'd just stick to something simple. I'd just get a tripod. Okay. You can just tilt the telescope up and down, or get a Dobsonian mount, again, tilt it up and down, and you can get computerized things, which I'll go into in a minute, which really help you even with those styles of telescopes. Equatorial mounts are really the sort of thing that you would have if you wanted to have stick it on a pole in your backyard, sort of permanently or semi-permanently. For beginners, I'd sort of avoid equatorial mounts.
Okay.
Now, the other thing is, for a certain amount of dollars, you get a large reflector or a smaller refractor or somewhere in between a compound telescope. Quality is better than size, okay? If you've got a certain amount of dollars and you've got a smaller, really good quality telescope you could buy, or a jumbo, not so good quality telescope, go for the smaller, good quality one, honestly, because you just get disappointed if you look through a low quality, cheapy telescope, and then it will just get shoved in a cupboard and you never use it again. So quality is better than size.
And I guess the other important thing also to remember is don't just focus on the magnification, because it's not about magnification, is it? It's really about how much light you're getting into your telescope.
Yeah, there are two things with the optics of telescopes. One is the aperture, which is the width of the tube of the telescope, not the length of it, but the sort of diameter of the telescope, because they're all sort of round tubes. So that's the aperture. The greater the aperture, the more faint light is coming in the front, and then you'll be able to see fainter things in the night sky. If you've just got a very small aperture, like 50 millimeters wide, 2 inches, you're not going to see a great deal out in space, to be honest. You'll get some good views of the moon, see the moons of Jupiter, you'll see the rings of Saturn, be able to look at some star clusters and things, but you're not going to see a great deal. But if you've got a 100 millimeter diameter aperture telescope, or a 4-inch one, you're going to see a lot more, because that has more light gathering power. Astronomers call it light gathering power. And you can imagine like this: if it's raining outside and you want to go collect some of the water, if you just take out a standard drinking glass and put it on the ground and try and catch some raindrops, you're going to get a few of them, right? If you take out a big bucket, a big wide bucket, stick it down, you're going to get a lot more rain, because you've got a lot more collecting area. And in fact, the large telescopes that are on these tilt and swivel mounts, they're called Dobsonians. They're very often called light buckets, because they just gather in more light. So that's important, because that'll determine a lot of the things you can see, and you can see many, many more things with a larger aperture telescope. But yeah, magnification also is important, because that will determine how big these things look or appear to be when you look through the telescope. But the important thing is, don't get fooled by the wild claims that you often see on the side of boxes of telescopes that you see in department stores, for instance, 500 times magnification, 800 times magnification, whatever. Sure, you can get that. You can get magnifications of that high, but no one ever uses magnification. All you will do is start magnifying the imperfections in the telescope,
exactly.
Right? There's a rule of thumb that basically says you take the aperture of the telescope in millimeters and you double that number, and that's the maximum magnification you're going to want. So if you've got a 4-inch wide telescope, which is 100 millimeters, double that number, you're never going to want to use more than about 200 times magnification.
And you can always change your magnification with a different eyepiece anyway.
That's right, yeah. The magnification all comes from these little eyepieces. Eyepieces are small optical things that you stick in the part where you look through, and you can take them in and out. You can get different ones. Yeah. There's dozens and dozens of different kinds. There are some that go for thousands of dollars. There are some that go for $50. Different qualities, different purposes, different designs and things. The eyepiece really makes it. Again, it's like having good tires on your car. And look, technically, you could get a mini Minor or something and put huge truck tires on it somehow, but you wouldn't. Okay, you'd use tires.
I have a neighbour who would do that. I have a neighbour that does that sort of thing.
That must be fun.
Only when he wants to tune his engine at 3 a.m.
See, astronomers are very quiet at 3 o'clock in the morning, because they're considerate. They're just out there looking at the stars. Now, the other thing is computer control. Computer control for telescopes is almost standard for most telescopes these days. I remember when computer control stuff started coming in 30-odd years ago, and a lot of astronomy purists, and perhaps even myself, thought, is this going to be a good thing? People aren't going to learn the night sky and learn how to find their way around and learn how to skip from one object to another, and in order to track down what they want to see. I've come completely around, and computer control is just magnificent. You have a little hand controller, and you type in, I want to see galaxy M31, and the telescope just goes zzz, zzz, and there it is. Right, absolutely brilliant. And in fact, the telescopes these days are so good that some of them have got sort of camera sensors on board where you switch it on and point it at two different directions in the sky, and it takes a picture of each of the two different directions you pointed it in, works out what stars are in those directions, so it therefore knows where you've pointed it, and then it knows how it is aligned, right, where north and south is, up and down, all that sort of stuff. And from then on, all night, you can just tell it what you want to see, and it will automatically swivel with motors, computerized drive that'll just point it to what you want to see. Absolutely brilliant. Fantastic for beginners. Takes all the hard work out of it. Now, the other thing to consider is where you're going to use it, how often you're going to use it, that kind of thing. So you can set your telescope up permanently in your backyard. You can either just stick a pole in the ground and attach it to that, or you can just have a permanent place to put your tripod, maybe a bit of, so you've got some concrete out the back or something, you can put some marks on the concrete for where your tripod legs are going to go, so you can put it always in the same spot. Some people can build an observatory. You can buy observatories, little fiberglass domes. You can get big ones, small ones, all sorts of ones. You can just get like a garden shed, a typical garden shed, and adapt it so that the roof just rolls off on rails. A lot of people use those. They just roll off roof observatories. They're often a lot less expensive than your typical round thing with a dome on it.
Yeah, but the dome looks so good. Come on.
They do look pretty cool, I must say, yeah. But the other thing is, some people don't have backyards, so, you might want to stick your telescope out on the balcony. So you probably want to use a tripod-style one. You can take it out, stick it on the balcony, do your observing, and then bring it back inside.
Yeah, we used to get a lot of comments at the ABC because we had in ABC Science, we had a large telescope there, a large Meade, and we just used to have that sitting in the office. We used it every now and then, but it was mostly just sit in the office, and the amount of comments you'd get, people would walk past and they'd stop and they'd walk over to it and they'd look at it and study it and be fascinated by it. So yeah, just having a telescope sitting there somewhere in the apartment or even on the balcony if it's waterproof is pretty cool.
Yeah, they're cool things to have. I mean, you might want to leave it out in your balcony in case it gets pinched or something, but it depends on your own circumstances. Look, you can even get little telescopes. They're called tabletop telescopes. They're just very small ones on very simple mounts. You just tilt up and down and go left and right, and they're great. And you can get little ones that are portable. You can take them on holidays with you. And I used to know a fellow who used to take really good pictures of comets and things. His telescope in his bedroom, looking out the window, just pointing out the window. Right? You can do a lot depending on where you are and what sort of circumstances you have, whether you've got a backyard, a balcony, or whatever. So the long and short of all of this about telescopes, you've got the three different kinds. Get a good mount. Don't believe the magnification height. Go for quality rather than size. Computer control is really good. The most important thing is to get a telescope you're actually going to use and not one that's going to sit in a cupboard. So if you're an absolute beginner, don't spend thousands on the most high-tech thing you can possibly get, and then get it home, take it out of the box and think, how on earth do I work this? All right? It's just going to be a waste. So I would suggest to start simple. Get your first telescope, a basic one, learn how it works, learn how to use them, and then you'll gradually learn what or work out what you want to see in the night sky. You might want to want to specialise on planets. You might want to specialise in galaxies or stars or this or that, and then you will know, okay, well, if I want to specialise in that, I'll need this kind of telescope or that kind of telescope. So go for one that you're actually going to use. And start small and dream big. That's what I would say.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a Science Report. A new study claims a mother's deficiency in vitamin D could explain why autism spectrum disorder is 3 times more common in boys than girls. The findings, reported in the journal Molecular Autism, found that vitamin D deficiency during pregnancy caused an increase in testosterone in the developing male brain. The research also showed that in vitamin D deficient male fetuses, an enzyme which breaks down testosterone was silenced, which could be contributing to the presence of high testosterone levels. Previous research has already found that vitamin D plays a crucial role in brain development, and that giving vitamin D supplements during pregnancy prevented autism spectrum disorder-like traits. New satellite images showed that the giant iceberg A68A could collide into South Georgia in the next few days, wreaking havoc around the impact point and threatening to wipe out the local wildlife, including massive penguin and seal colonies. With a surface area of some 5,800 square kilometres and weighing an estimated 1 trillion tonnes, this giant iceberg is twice the size of Luxembourg and larger than the state of Delaware. Since its birth in 2017, the iceberg's travelled thousands of kilometres from the Larsen C ice shelf in Antarctica and is now less than 100 kilometres from South Georgia. If it remains on its current path, the iceberg could ground in the shallow waters offshore within days. The last time something like this happened, there was a massive die-off of penguins, as the giant berg prevented adults from returning to feed their chicks. Satellites, including the European Space Agency's Copernicus Sentinel-1 radar mission, have been tracking the iceberg over its journey for the past 3 years. A new study warns that an estimated 31% of the world's oak tree species are now threatened with extinction. The findings by the Mortem Arboretum and the International Union for Conservation of Nature details for the first time the distributions, population trends and threats facing the world's estimated 430 oak species. Scientists found 41% of oak species are of conservation concern, and nearly a third, some 31%, are already considered threatened with extinction. The analysis reveals that invasive pests, diseases and climate change are the key threats to oaks in the United States, whereas deforestation for agriculture and urbanization remain the biggest drivers of change in Southeast Asia. A new study claims dogs can tell a nonsense word from a real one, but only if they don't sound too similar. A report in the Journal of the Royal Society Open Science looked at how well companion dogs could distinguish nonsense words from real commands. Dogs have a vocabulary of around 60 words, and the new research shows that those used to a greater range of commands were better able to tell apart similar-sounding nonsense words from real ones. The authors think that the way dogs focus on phonetics may be similar to how infants start learning words. The study found that dogs easily recognized words like sit, and they understood that this was different to nonsense words like beep. But they had more difficulty in determining the difference between sit and a similar-sounding nonsense word like sat. A new study by Murdoch University has highlighted chiropractors' continuing use of the spinal manipulation therapy subluxation to try and enhance the body's immune function. This dangerous treatment lacks any scientific proof that it works. And Tim Mendham from Australian Skeptics says it all raises serious concerns about informed consent.
Yeah, there's a recent paper published on this by a number of academic authors, including one who's a chiropractor, who was saying that the trouble is that a lot of chiropractors are promoting a range of treatments and underlying conditions that are not necessarily supported by science. Now, the classic one is the subluxation, which is the misalignment of the spine causing a whole range of different ailments. Everything from obviously bad back, that sort of stuff is fine. A bit of manipulation, a bit of massage there is not a great issue, although it might be, all the way up to sort of areas like bedwetting, asthma, bad dreams, blah, blah, blah. The whole concept of the subluxation is not proven at all. In fact, there's a lot of chiropractors who say it's bunk and that it really should be dropped and should have been dropped 100 years ago. But a lot of chiropractors are still claiming it and still using it as an indication. So the trouble is the advice they're giving their patients is not founded on good information. And therefore the issue is with this paper that they talk about is that a lot of people are not having a proper ability to give their consent to practices. And some of these practices, beyond just the massage and give it back, etc., can be extremely dangerous. And one in particular is the swift manipulation of your head and neck. Now, if you've ever seen chiropractors do this, they basically take your head in the two hands and then twist it suddenly, like wham, crack.
Isn't that the same movement that James Bond does to kill people?
Yes, pretty much. Yeah, the suggestion is it has killed people. That it's not necessarily they don't hold it so the person just dies with a broken neck, but it can come very close to that because the carotid artery can be severed and the person can die of a stroke. And some people have had strokes straight away. Some people have strokes, might be days down the track when the damage has been done to their arteries, whatever. Manifests itself. This is a classic case of if chiropractors are recommending a treatment which can kill you, you can wonder about what sort of consent people are going to give to that sort of thing. Now, there's not a lot of cases, you have to say, if there was to be a major uproar. And the trouble is you can't always attribute it exactly to a chiropractic treatment because it might happen sometime later, right? But the issue is that there is a danger, certainly a danger there of the practice doctors. Now, in traditional evidence-based medicine, things go wrong. It's often misdiagnosis or mistreatment. It's something which is they shouldn't be doing, but in the chiropractic sense, this is something they regard as something they do and should do, and it has a dangerous effect. So perhaps they shouldn't do it. The same as when they were cracking the backs of infants, and I'm talking about day-old infants, and where they put a baby on their lap and go whack and crack the spine of a baby. They're now banned from doing it.
I think the problem is that chiropractors aren't medically trained doctors. They act as if they are in many cases, but they're not.
Yeah, the use of the term doctor is a problem.
Yes.
Actually, yeah, the use of the term doctor is pretty loosely applied all over the place to people who may not actually be doctors, whether it's medical training or not. There's a lot of people who treat people in, quote, medicine, unquote, who claim to be doctors, like naturopaths claim to be doctors. And basically, what's the rules for applying doctor? Pretty loose. And therefore, you're in the situation where anyone can say, I'm a doctor, therefore trust me.
Yeah, you can even get a PhD from the University of Wollongong these days.
Yes, absolutely. And it's not just the most recent one that a lot of skeptics have looked at, which is the anti-vaccination PhD, which we have discussed in our latest issue of our magazine, but it's also, there's a whole range of some very, very strange PhDs being issued over the years out of that institution and probably other institutions as well. There's some funny things that are put out there under the guise of freedom of speech. That, freedom of speech is not free to actually tell rubbish, right? And that's part of the problem that's happening within universities.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.